Hello students, this is my lecture number 2 on binomial theorem. In this lecture, we will discuss number of terms in the expansion of x plus a whole power n plus or minus x minus a whole power n, finding the coefficient in the binomial expansion and finding independent term, and the fourth part is finding middle terms in the binomial expansion. Before watching this lecture, watch my lecture number 1 for better understanding. So let us start lecture number 2. Now we are finding expansion of x plus a whole power n plus x minus a whole power n. First expand x plus a whole power n and after that x minus a whole power n. When you add these two expressions, you will get another expression. Right, x plus a whole power n equals to nc0 x power n plus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a square plus nc3 x power n minus 3 a cube plus nc4 x power n minus 4 a power 4 and so on. Next we'll take x minus a whole power n expansion, nc0 x power n minus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a square minus nc3 x power n minus 3 a cube plus nc4 x power n minus 4 a power 4 minus so on. Here we will get alternate signs. By adding these two expressions, the right hand side plus minus terms, plus minus terms gets cancelled. The remaining terms are, now LHS observe this, x plus a whole power n plus x minus a whole power n equals to 2 into nc0 2 terms, so 2 into nc0 x power n plus nc2 x power n minus 2 a square. See here we have two terms are there, nc0, that's why you are writing 2 into nc0 x power n. nc2, two terms, 2 into nc2 x power n minus so on. Next nc4, 2 into nc4, we are writing outside 2. Okay, here x plus a whole power n plus x minus a whole power n will be 2 into nc0 x power n plus nc2 x power n minus 2 a square and so on. That means here we will have even suffixes 0, 2, 4, 6 we will get by adding these two expressions. Next we will discuss what is by subtracting these two expressions what will happen. Now expansion of x plus a whole power n minus x minus a whole power n. See x plus a whole power n, once again I am writing expansion, nc0 x power n plus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a square plus nc3 x power n minus 3 a cube and so on. Next another expansion, x minus a whole power n expansion, nc0 x power n alternate signs minus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a square minus nc3 x power n minus 3 a cube plus nc4 x power n minus 4 a power 4 and so on. Here you have to subtract. When you subtract this, we will get this is minus and here this will be cancel minus, these two gets cancelled. This will be plus, so this is plus. So now subtracting both, we will get 2 into nc1 x power n minus 1 a power 1 plus nc3 x power n minus 3 a cube and so on. See if you observe that this is the required expansion. Here we are subtracting these two expressions, that's why I am writing signs are changed, minus, this is plus minus, minus becomes plus becomes minus, minus becomes plus. Now plus becomes minus. Now plus nc0 minus nc0 terms cancel, plus nc2 minus nc2 cancel, plus nc4 minus nc4 gets cancelled. The remaining terms are here nc1, 2 into nc1 x power n minus 1 a power 1, nc3, 2 into 2 I am writing outside the bracket. So this is the expansion of x plus a whole power n minus x minus a whole power n. Now in this we have to remember here odd suffixes are there. By subtracting these two expressions we will get 1, 3, 5 and so on. We can extend up to any number we will get that is depends on index. When n is 5, we have to write up to 5c5. Now we will discuss number of terms in the expansion of x plus a whole power n plus x minus a whole power n. With the help of example, we can identify the number of terms in this expansion. For example, I am taking here we will have two cases. Number one, n is even. N is even how many number of terms after expansion of these two. For example, let n equals to, I am taking 2. That implies x plus a whole square plus x minus a whole square. Expand it, x square plus a square plus 2ax, a plus b whole square, x square plus a square minus 2ax. Here plus 2ax minus 2ax gets cancelled. These are x square plus x square, you can join 2 into x square plus a square. So after cancellation of some terms plus 2ax minus 2x, we are getting two terms. These are two distinct terms. We have to identify number of distinct terms. Remaining terms are how many here? Number of terms in this expansion. Therefore, number of terms equals to 2. If you take another example, let n equals to 4. X plus a whole power 4 plus x minus a whole power 4. What are the remaining terms? According to our previous discussion, need not expand all. Directly you know this will be what? 4c0 x power 4. Next plus all even suffixes 4c2 x power 4 minus 2 a square. Last next even number is 4c4 last x power 0 a power 4. Here only 0 to 4 suffixes, because if it is plus even suffixes. N is 4, we have to expand up to 4. How many number of distinct terms are there? 1, 2, 3. So number of terms here, number of terms equals to 3. With these two examples, we have to generalize this. So using these two examples, I am writing the formula is number of non-zero terms in this expansion equals to, I am writing directly, n by 2 plus 1. This gives these two answers. For example, in the first example, if you take n equal to 2, you are getting 2 number of terms. Substitute here n equals to 2, you will get same. N equals to, substitute 2 by 2 plus 1. So 1 plus 1, 2. So how many number of terms are there? 2 terms. Similarly, in the second example, here n equal to 4, if you substitute n equal to 4 in this, here 4 by 2 plus 1, that is 2 plus 1. So number of terms are 3 equal. So when n is even in the expansion x plus a whole power n plus x minus a whole power n, number of non-zero terms, the formula is n by 2 plus 1. This is the formula for number of terms in this expansion. We'll discuss case 2. If n is odd, I'm taking some examples. Let n equals to 3. What about the expansion? This x plus a whole cube plus x minus a whole cube. This expansion is according to our previous discussion 2 into, here plus is there means all even suffixes, 3c0 x cube plus 3c2 x power 3 minus 2 1 a square. Only number of terms are 2. After expansion, some positive negative terms gets cancelled. Number of distinct terms only 2. Now I am taking another example. Let n equals to 5. What will happen? Number of terms. X plus a whole power 5 plus x minus a whole power 5. After expansion, we will get 5c0 x power 5. Next even suffix 5c2 x power 5 minus 2 3 cube a square. Next 5c4 x power 5 minus 1 1. Next a power 4. That's all. Only up to 4 even suffixes we should write. How many number of distinct terms? Again here 3. Now here we are getting 2 and this example 3. We can generalize one of the formula we can write here. After expansion, number of terms equals to, I am writing the formula n plus 1 by 2. This is suitable for these two examples also. For example, in the first example, if you write n equal to 3, 3 plus 1 by 2, 4 by 2, 2. Correct answer. So next, for the second example, index is 5, substitute n place 5. 5 plus 1 by 2, that is 6 by 2, 3. Getting same answer here also. So this formula gives number of non-zero terms in the expansion of x plus a whole power n plus x minus a whole power n. Similarly, here also same discussion applicable for this also. Same discussion applicable for this x minus a whole power n minus x minus a whole power n. Here also two cases will arise. Number one, if n is even, number of terms in the expansion equals to number of terms in the expansion equals to this expansion means equals to n is even, the answer is n by 2. Next case 2, if n is odd, number of terms in the above expansion, same expansion formula n plus 1 by 2. Number of non-zero terms in the expansion of x plus a whole power n plus x minus a whole power n. Here two cases will arise. When n is even, how many number of non-zero terms are there after expansion? And when n is, first one, n is even, how many number of non-zero terms? In the case 2, n is odd, number of non-zero terms after expansion. When n is even, the number of non-zero terms in this expansion is n by 2 plus 1. This is the formula. When n is odd, number of non-zero terms in this expansion, after expansion, we will get n plus 1 by 2 number of terms. Next, in the case of number of terms in the expansion of x plus a whole power n minus x minus a whole power n. Here also will arise two cases. Number 1, n is even, 2, n is odd. Here the formula is n is even, number of non-zero terms after expansion will get n by 2. When n is odd, n plus 1 by 2 same. Using this formula, we can find out number of non-zero terms in the expansion of x plus a whole power n minus x minus a whole power n. Observe this. Find the number of terms in the expansion of 4x minus 7y whole power 49 plus 4x plus 7y whole power 49. Actually, after expansion here we will get 50 terms. In this also we will get 50 terms. Total 100 terms. But sum of positive, some negative terms gets cancelled. After cancellation of positive negative terms, how many remaining terms they are asking? How many distinct terms are there? So here depends on n here. N equals to what? N equals to 49. 49 is odd. Therefore, according to our formula, x plus a whole power n plus x minus a whole power n. When n is odd, number of distinct terms equals to formula n plus 1 by 2. Here n is 49, so 49 plus 1 by 2, 50 by 2. So after cancellation, how many number of terms are remaining means 25 number of terms are remaining. Using the previous discussion, we have to find out the integral part of root 2 plus 1 whole power 6. Integral part means integer value you should write. Here square root is involving. With this simple example, you can understand which part you should find. For example, root 2 whole square, for example, root 2 plus 1 whole square. If you expand this by using a plus b whole square, a square, root 2 whole square 2 plus b square 1, 2ab, 2 root 2. This will be 2 plus 1, 3 plus 2 into root 2 value 1.414. That implies 3 plus multiply these two, so 2.828. When you add these two, 5.828. That means this can express as 5 plus 0.828. Here this part is known as integral part. This part is called fractional part. So in this simple example, small example, what is integral part of this expansion is 5. The integral part of root 2 plus 1 whole square expansion is 5. This is the answer for this question. This is fractional part. In the same way, you can't solve this problem because here whole power 6 is there, expansion will be difficult. After that, after expansion, calculations will be difficult. So one of the procedure is there to solve this example. Root 2 plus 1 whole power 6 I am taking. Let root 2 plus 1 whole power 6 equals to I plus f. According to our previous discussion, this expansion gives some integral part and fractional part. In this question, we have to find out only integral part, means I value required. Finally, we should find I value. This is equation 1. Here f is also fractional part. That's why 0 less than f less than 1 I am taking as equation 2. Now we are assuming that this is the procedure. Let root 2 minus 1 whole power 6 I am taking as small f. Now we are going to find out range of small f also. We know that 1 less than root 2 less than 2. Root 2 value is always lies between 1 and 2 because root 2 value is 1.414. So here taking minus 1 on both sides, that implies 1 minus 1 less than root 2 minus 1 less than 2 minus 1. 0 less than root 2 minus 1 less than 1. Taking power 6 on both sides, 0 power 6 is 0 less than root 2 minus 1 whole power 6. 1 power 6 is 1. This means how much? Root 2 minus 1 whole power 6 is f, small f. That's why we got 0 less than small f less than 1. This is I am writing as equation number 3. So that means small f is also some fractional part which is lie between 0 and 1. After that, I plus f plus small f value find out first. What is I plus f? Root 2 plus 1 whole power 6. What is small f? Root 2 minus 1 whole power 6. Simplify this. Expand by using previous discussion, we have x plus a whole power n plus x minus a whole power n whole power 6. Here n is even. That means we will have, if it is plus means here we will have 2 into what are remaining terms? Even suffixes 0, 2, 4, 6 we will have. Here root 2 whole power 6 minus 0, 6. Next 6c2 root 2 whole power 6 minus 2, 4. Next 1 power need not write, 1 power 2. Next 6c4 root 2 whole power 6 minus 4, 2 plus 6c6 root 2 whole power 6 minus 6, 0. If you calculate all these values, we will get total is, it is 198. That implies I am getting what? I plus f plus small f equals to 198. 198 is one of the integer, but here we have to find only I. So therefore, I plus f plus small f equals to, this is even integer. 198 means even integer. Now 2 and 3 we are going to add next. 2 plus 3 implies what will happen? 2 plus 3. 2 means 0 less than capital F less than 1. 3 means 0 less than small f less than 1. Adding these two, 0 less than capital F plus small f less than 2. That implies capital F plus small f lies between 0 and 2. Remember this point. Next, we have what is I plus f plus small f? We are getting even integer, 198 even integer. This implies capital F plus small f we can find out even integer minus I. Even integer minus integer always integer. So capital F plus small f I am getting one of the integer. Even integer means some, for example, even integer is 4. Any integer take, for example, 1. 4 minus 1, 3 integer. Even integer means 8. Take one integer 2. 8 minus 2, 6 integer. So even integer minus integer is always integer. So next, observe these two. Capital F plus small f is integer and which lies between 0 and 2. So the integer lies between 0 and 2 only 1. Therefore, capital F plus small f value will be 1. So according to our previous equation, from this equation once again this is I plus f plus small f equals to 198 I am taking. We have I plus capital F plus small f equals to 198. Now we have capital F plus small f is 1. So I plus 1 equals to 198. That implies I equals to 198 minus 1, 197. Therefore, integral part of root 2 plus 1 whole power 6 equals to 197 is the correct answer. Next, another example, some important example. Find the number of irrational terms in the expansion of fifth root 3 plus cube root 7 whole power 36. Asking here number of irrational terms. Actually, this is the index is 36, which will have total number of terms after expansion. 37 terms we will get. In that 37 terms, some terms will be rational and some terms will be irrational because here radicals are there, fifth root and cube root. That's why some of the terms will be irrational, some of the terms will be rational. In this question, they are asking only irrational terms. We have one of the formula. Use this formula, easily we'll get this answer. The number of rational terms, see, this is formula for rational, not irrational. First find rational terms. After that you automatically will get irrational also. Number of rational terms in the expansion of p root a plus q root b whole power n is step n by pq plus 1. This is the step function. If n is divisible by p or q, these two cases will arise here. If n is divisible by p or q, the formula is step n by pq plus 1. If n is not divisible by p or q, apply this formula step n by pq. Here this is greatest integer function. Step means greatest integer function. It represent greatest integer function. See, in our example, p is 5, q is 3. P equals to 5, q equals to 3 and n equals to 36. Here 36 is divisible by 3. Therefore, we will take here first case. First case is suitable for this question. Why? 36 is divisible by at least one of p and q. Here 36 is divisible by 3. Therefore, the first case is applicable. So therefore, number of rational terms equals to number of rational terms equals to formula step n by pq plus 1. N is 36 by pq. So 5 3s are 15 plus 1. Now 36 by 15 will be 2.4. Step 2.4 plus 1. Step 2.4 is 2. 2 plus 1. So number of rational terms are 3. So they are asking here irrational terms. So number of irrational terms equals to total number of terms minus number of rational terms. How many? Here 36 is index. So total number of terms 36 plus 1. 37 minus rational terms I got 3. 37 minus 3 will be 34. So number of irrational terms equals to 34 number of terms are there. Now we have to find out coefficient and independent term in the given binomial expansion. With the help of example, you can understand what is coefficient, what is independent term. For example, I am taking one of the example x plus 2 whole cube. With the help of binomial theorem, expand it. 3c0 x cube, 3c1 x power 3 minus 1 into 2 power 1, 3c2 x power 3 minus 2 is 1 and 2 power 2, 3c3 x power 0 2 cube. Here you have to remember binomial coefficients are different, coefficients are different here. These 3c0, 3c1, 3c2, 3c3 are called binomial coefficients. They are called binomial coefficients. But if they ask coefficient of x square, if they ask what is the coefficient of x square, except x square remaining part, 3c1 into 2 is called coefficient of x square. But only 3c1 is called binomial coefficient. That is the difference. If they ask coefficient of x, what is coefficient of x here? 3c2 into 2 square, that is coefficient of x. 3c2 into 2 square, that is 4. This is called coefficient of x. But binomial coefficient, only 3c2 is called binomial coefficient. Here, this 3c0 is known as coefficient of x cube. But here independent term in this expansion means without x term is called independent term. Without x term is called independent term. Here in the last term there is no x. That's why this is called independent term. That's why here independent term means 3c3 into 2 cube, that is 8, 3c3 1. So 8 is here independent term. So whenever the binomial expansion if you find, you will get the coefficients and independent terms also. Independent terms without x terms are called independent terms. If another example, for example, x plus 1 by x whole square. With the help of a plus b whole square, x square, a square plus 2ab plus b square. That means x square plus 2. 1 by x square can be written as x power minus 2. This is 1 by x square. Now, if they ask, for example, coefficient of x square. Coefficient of x square is 1. Here, coefficient of x power minus 2 equals to how much? 1. What is 2? 2 is known as independent term or coefficient of x power 0. 2 can be written as 2 into x power 0 also we can write. Therefore, this is 2 is known as coefficient of x power 0 or independent term. Remember, independent term means without x term. In this term, there is no x, that's why this is called independent term. Now, I will take one of the problem, how to find coefficient of the binomial expansion. See, this is the problem. Find coefficient of x power 11 in the expansion of 2x square plus 3 by x cube whole power 13. Here, by expanding complete terms, you will get total 14 terms. In that 14 terms, you will get one of the term as a coefficient of x power 11. But expansion and finding coefficient of x power 11 will be difficult. That's why by using general term formula, we can solve the problem. So you start with general term. TR plus 1 equal to general term NCR x power n minus r a power r. This is the general term formula. Substitute here. N is 13. 13CR, x means here 2x square whole power 13 minus r into a power r means 3 by x cube whole power r. The procedure 13CR, and here we can write a constant. First I am writing 2 power 13 minus r into 3 power r. Next x square whole power 13 minus r. X square whole power 13 minus r, that will be 26 minus 2r into, this is 1 by x cube, right in numerator, x power minus 3r. X power minus 3r. Now here bases are equal, power should be added. That implies 13CR 2 power 13 minus r into 3 power r into x power 26 minus 2r minus 3r. That implies 13cr 2 power 13 minus r into 3 power r into x power 26 minus 5r. This is equation 1. Here we have to find out coefficient of x power 11. This is important step. To get coefficient of x power 11, we have to equate this term will be 11. We have to equate this step 11. If the power is 11, this total completely will be coefficient of x power 11. If it is 11, what will happen? This is x power 11. That means this term is known as, this part is called coefficient of x power 11. That's why to get coefficient of x power 11, we are equating 26 minus 5r equal to 11. To get coefficient of x power 11, equate 26 minus 5r equals to 11. That implies 5r equals to 26 minus 11, 15. That implies r equals to 3. This r value substitute in 1. From 1, coefficient of x power 11 equals to, this is equation 1. Substitute r plus 3. Here you will get coefficient of x power 11. 13c3, 2 power 13 minus 3, r plus 3, 3 power 3. R plus I am substituting 3. That means 13c3 into 2 power 10 into 3 cube. This is called coefficient of x power 11 in the given expansion 2x square plus 3 by x cube whole power 13. Now we are going to start independent term. How to find independent term in the given expansion? Already I said independent term means without x term. This is given binomial expansion. Same formula use. Find out first general term. After that find r and corresponding value you will get. See, given expansion general term. Formula tr plus 1 equal to ncr x power n minus r a power r. That implies n is here 25. 25 cr. X means here this is 3 by cube root x whole power 25 minus r into pi root x whole power r. Now simplify this. 25 cr 3 power 25 minus r. This is 5 into 5 power r cube root x here means x power 1 by 3 right in numerator, that will be x power minus 1 by 3. So finally x power minus of 25 minus r by 3 into here square root of x means 1 by 2. So x power 1 by 2 whole power r, that is r by 2. Now bases equal here, power should be added. Simplify this. 25 cr 3 power 25 minus r into 5 power r into x power minus 25 plus r by 3 plus r by 2. Same step I am writing here. Take LCM here. 25 cr 3 power 25 minus r into 5 power r into x power, by taking LCM here 6 minus 50 plus 2r plus 3r. This is equation 1. To find coefficient, here they are asking here independent term. So to find independent term, this power must be equate 0. If it is 0, x power 0 will be 1. Automatically x will be eliminated. That means without x term means this is known as independent term. That's why to get independent term, this power must be equate 0. So therefore, to get independent term, equate minus 50 plus 2r plus 3r. by 6 equal to 0. That implies 5r minus 50 equal to 0. 6 into 0. So 5r equals to 50. R equals to 10. That implies R equals to 10. So this value, R value, substitute in equation 1, we will get independent term. So substitute R equals to 10 in equation 1. That implies independent term equals to, without x term is known as independent term. Substitute here 25 C10, 3 power 25 minus 10, that is 3 power 15 into 5 power 10. This is called independent term. Here if you write R value 10, this will be 0, x power 0, 1. So this term is known as independent term in the given expansion. Now another problem, finding coefficient in the binomial expansion. This is previous JEE Mains 2019 question. The positive value of lambda for which the coefficient of x square in this expansion, x square into root x plus lambda by x square whole power 10 is 720. Coefficient of x square given, that is 720. They are asking here lambda value. Lambda is positive here. First, you have to find out coefficient of x square first. Equate 720, we will get lambda value. That is the process. First write general term as usual process. General term in the given expansion, TR plus 1 general term. Given expansion here x square into formula. This is binomial expansion. So NCR here 10 CR, n is 10 in this, n is 10. So root x whole power 10 minus r into lambda by x square whole power r. This is general term in the given expansion here, x square into root x plus lambda by x square whole power 10. That means every term is multiplying with x square. If you expand, you will get 11 terms. All these 11 terms, each and every term must be multiplied in with x square. Why? Here x square given, that's why. That's why I am writing in general term also x square here. X square as it is, general term writing in this bracket. Now simplify this. 10c, I am writing some constants first. 10cr, this is root means 1 by 2. Here lambda power r another constant. Remaining all x terms I am writing x square. Next root x, square root of x means here this is 1 by 2. So x power 10 minus r by 2 into x power minus 2r. 1 by x square, write in numerator minus 2r. Now here all these three bases are x, that's why power should be added. 10cr lambda power r into x power 2 plus 10 minus r by 2 minus 2r. Now take LCM and here they are asking here coefficient of x square. So equate, this is I am writing as equation 1. Now to get coefficient of x square, this part total must be equals to 2. Must be equals to, if it is 2, this power total is 2, then this will be x square. That means this value will be coefficient of x square. That's why to get coefficient of x square, equate 2 plus 10 minus r by 2 minus 2r equals to 2. Take LCM here 2. 4 plus 10 minus r minus 4r by 2. This is 2. That implies minus 5r, 14 minus 5r. 4 plus 10, 14 minus 5r equals to 2 2s are 4. So therefore 10 equals to 5r, that implies r equals to 2. Substitute r equals to 2 in equation 1. That implies coefficient of x square equals to 10c2 lambda power 2. Already given coefficient of x square is how much? 720. In our question coefficient of x square is given 720, therefore 10c2 lambda square equal to 720. 10c2 means here 10 into 10c2 10 into 9 by 2 into 1 into lambda square equal to 720. By simplifying this, total lambda square value will be lambda square equals to 16. That implies lambda equals to plus or minus 4. But here, since lambda is positive, since lambda is greater than 0, therefore correct answer is lambda equal to 4. First option is the correct option. This is another previous JEE Main 2020 question. The coefficient of x power 7 in the expansion of 1 plus x whole power 10 plus x into 1 plus x whole power 9 plus x square into 1 plus x whole power 8 so on x power 10 required. So write given expansion. Given expansion equals to, here 1 plus x whole power 10 is there, that's why I am writing 1 plus x whole power 10 as common. For each term I am writing 1 plus x whole power 10 as common, that's why first term is 1. In this term here there is no 1 plus x, that's why divide with x into 1 plus x, 9 by 1 plus x whole power 10 plus x square into 1 plus x whole power 8 by 1 plus x whole power 10 so on x power 10 by 1 plus x whole power 10, because we are writing 1 plus x whole power 10 as common, that's why here we are writing as a division 1 plus x whole power 10. Now this will be 1 plus x whole power 10, 1 plus, now here x plus 1 plus x whole power 9, here 1 plus x whole power 9, complete cancel, 10 cancel, so that is x by 1 plus x. In the next step here 1 plus x whole power 8 complete cancel, here 2 is there. So x by 1 plus x whole square, x by 1 plus x whole square, and so on last x by 1 plus x whole power 10. Now this is in the form of GP series, a plus ar square so on a into r power 10. Formula, GP formula, a plus ar square plus so on a into r power n minus 1 equals to a into 1 minus r power n by 1 minus r. If you compare these two, a equals to here 1, r equals to x by 1 plus x. What about n here? N minus 1, here n minus 1 is 10. So n minus 1 equals to 10, that implies n equals to 11. So these values substitute in our formula. So 1 plus x whole power 10 into a is 1 minus r power n, r means x by 1 plus x, then we are getting 11 by 1 minus r, x by 1 plus x. This is 1 minus r power n by 1 minus r. Take LCM as 1 plus x. 1 plus x whole power 10. Here LCM denominator 1 plus x whole power 11. So 1 plus x whole power 11 minus x power 11 by 1 plus x whole power 11 into, here denominator LCM is 1 plus x, I am writing here 1 plus x by 1 plus x into 1 plus x minus x. This denominator I am writing here numerator. So 1 plus x, 11 gets cancelled, here 10 is there, plus x minus x gets cancelled. So finally 1 plus x whole power 10 into 1 plus x whole power 11 minus x power, this is x power 11. So x power 11 by 1 plus x whole power 10. So these two gets cancelled. Final expansion will be 1 plus x whole power 11 minus x power 11. Now here asking coefficient of x power 7. So the coefficient of x power 7, here we will get coefficient of x power 7. So what is coefficient of x power 7? The expansion is here like this in this model. Easily we can expand this. 11c0 plus 11c1x, 11c2 x square, so on, 11c7 x power 7 and so on. The coefficient of x power 7 equals to here 11c7. So 11c7 value 11 into 10 into 9 into 8 by 4 into 3 into 2 into 1. 8 cancel 3 times. So 11 into 30, answer is 330. So second option is correct option. Now let us start. What is middle term? How to find middle term or middle terms? And what is greatest binomial coefficient? And how to find greatest binomial coefficient? With the help of the examples, we can understand what is middle term, how to find middle term. Similarly, we can identify binomial, greatest binomial coefficient also. First example, a plus b whole square. You know this expansion, a square plus 2ab plus b square. Total we will have 3 terms here. Index is 2, 2 plus 1, total number of terms 3. T1, T2, T3. Here, this term 2ab is middle term. Clearly, why? Left hand side we will have one term, right hand side one term. That's why T2 is exactly middle term. Here n is even, only one middle term exists. Index n is even here. Middle term only one exists. And n is even case. See here, observe the binomial coefficients in this. The binomial coefficients are 1. The binomial coefficients are 1, 2, 1. Here 2 is coefficient of middle term or binomial coefficient of middle term. Here 2 is binomial coefficient of middle term. Which is greatest? Observe this. This is 1, this is 1, 2 is greatest here. So that's why this 2 is called greatest binomial coefficient, GBC. That means the coefficient, the binomial coefficient of the binomial coefficient of middle term. The binomial coefficient of middle term is greatest binomial coefficient. Remember, this is T2 is middle term. The binomial coefficient of middle term is greatest binomial coefficient. Next, I am taking another example. A plus b whole cube. A cube plus 3a square b plus 3ab square plus b cube. Here terms are T1, T2, T3, T4. See, there is no here clearly single term cannot be middle term. See, observe this total number of terms here we have. Index is 3, number of terms are 4, but exactly one term is not a middle term, because if you take T2 as middle term, left hand side only one term, right hand side we have 2 terms. If you take T3 as middle term, we have left hand side is 2, right hand side only 1. So that's why we are treating these 2 terms, T2 and T3 terms, we are treating as middle terms. Therefore, when n is odd number, index is odd, number of middle terms, how many number of middle terms are exist? Number of middle terms are 2 always. Whatever the index here, n is even, only one middle term is exist, n is odd, 2 middle terms are exist. Now, we are going to write how to find middle term when index is n, I will give one of the table to identify middle term and greatest binomial coefficient. Here, this is the table. Index even or two cases are exist, always index is n, index n, even odd cases exist, and the number of middle terms. We have discussed already. When n is even, index n here. When n is even, number of middle terms only one. When n is odd, two middle terms are exist. Next, when n is even, what is middle term? This is the formula to identify middle term. T n by 2 plus 1. That means n by 2 plus 1th term is the middle term. Greatest binomial coefficient for this is NC n by 2 is called greatest binomial coefficient. When n is odd, two middle terms are exist. The middle terms are here n plus 1 by 2th term and n plus 3 by 2th terms are called middle terms. What are the greatest binomial coefficients means? The coefficients of middle term. Here this is NC n minus 1 by 2 and NC n plus 1 by 2 are called greatest binomial coefficients. These are the formulas to identify even and odd cases. Here Y greatest binomial coefficient is NC n minus NC n by 2. Here Y greatest binomial coefficient is NC n by 2, you have to find out. For example, take general binomial theorem expansion. This is given binomial expansion x plus a whole power n. In this binomial expansion, find out t n by 2 plus 1. T n by 2 plus 1th term required. T n by 2 plus 1th term. Before writing this, find general term. What is general term? T r plus 1 equal to NCR x power n minus r a power r. Now here r is n by 2, that's why NC n by 2 x power n minus n by 2 into a power, a means here a only, a power r. R means here n by 2. So what is the binomial coefficient? This is middle term actually in this when n is even case. This is the greatest binomial coefficient. This binomial coefficient is known as greatest binomial. That's why the coefficient, the binomial coefficient of t n by 2 plus 1th term is nc n by 2. The binomial coefficient of t n by 2 plus 1 equals to nc n by 2. This is greatest binomial coefficient. In the next case, now in odd case, n is odd case, two middle terms are exist. Take binomial expansion same x plus a whole power n. We will have two middle terms. First write t n plus 1 by 2th term. This can be written as n minus 1 by 2 plus 1. We are converting in the form of t r plus 1 form. That is main important. We should write general term. For that purpose, this expression I am writing t r plus 1. If you take LCM 2 plus 2 minus 1 plus 1. So t n plus 1 by 2 both are equal. So this is now in the form of t r plus 1. Here r means n minus 1 by 2. Write general term formula NCR means n minus 1 by 2. X power n minus 1 by 2 into a power r means n minus 1 by 2. Here what is binomial coefficient? NC n minus 1 by 2. Therefore this is greatest binomial coefficient. This total term is middle term. The binomial coefficient is called greatest binomial coefficient. In the similar manner, we can write another binomial greatest binomial coefficient is NC n plus 1 by 2. But these two are equal always. NC n minus 1 by 2 is nothing but NC n plus 1 by 2. These two values are equal. When you take n equal to odd, for example, if you substitute n equal to 3, so 3 minus 1. 3 minus 1 is 2, that is 3c1 equals to here 3c 3 plus 1 4 by 2 2. This is 3 plus 1, 4. 3c1 equals to 3. 3c1 value is 3 only. Next 3c2 is also 3. If you expand, you will get 3. So both are equal always. When in the odd case, nc n minus 1 by 2 is equals to nc n plus 1 by 2. All are both always equal. This is about middle term and greatest binomial coefficient. The binomial coefficients are nc0, nc1, nc2, so on, ncr, and so on, ncl. In these all binomial coefficients, the greatest binomial coefficient is ncr. This is greatest binomial coefficient. But where? What is r? R equals to step n by 2. This is important. Here, step denotes greatest integer function.